We move today from talking about amplitudes and period changes to what we call phase shifts and vertical translations. And a phase shift is basically a fancy word for just doing a horizontal translation. One of the things you'll also notice in this general formula, today I've changed the plus C to a minus C when you can reflect on a couple days notes ago. I did that because I wanted to be in agreement with our book. Several books I've used had a k theta plus C form. Our book uses a k theta minus C, so we'll go k theta minus C. H in this formula represents the exact horizontal or vertical translation of our graph. C doesn't necessarily reflect the horizontal translation. In fact, the horizontal translation is calculated by taking the C value over the K value. That's going to get you your left and your right shifts. Now, what we can also do, and what I would recommend if I don't have a coefficient of 1 in front of my theta, factor that out, and then this term that's left is your actual horizontal translation of C over K. Let's do a couple of problems. Now I look at this problem and I notice that it's not in k theta minus C form, so I rewrite sine x minus negative pi over 3. Going to calculate some things right now. We'll go amplitude. It's 1. K is equal to 1. Therefore, period is equal to 2 pi. Intervals equals 2 pi over 4 pi over 2. And you'll notice my phase shift is exactly, since this has a coefficient of 1 in front of it, negative pi over 3. And vertical translation is 0, because there is no K value. What I also need to know now is that if I'm going to graph this, I need to have all my intervals set up correctly. So I see that this starting point is a translation back of pi over 3. However, if I'm going to add pi over 2 to that, they don't have common denominators, so that's going to be a tough add. I'm going to take and find common denominators of 2 and 3, which is 6, and change these to 6, so it's just easier to add. So this is 3 pi over 6 here, and this is 2 pi over 6 here. So I'm going to rewrite this as 2 pi over 6 and start adding 3 pi over 6 to that. So if I add positive 3, I get pi over 6. Positive 3 again gets me 4 pi over 6. Positive 3 again, 7 pi over 6. And positive 3 again is 10 pi over 6. And you'll notice I'm going from negative 2 to 10, which is 12 over 6, or 2 pi. So there's everything I need. This is a standard sine graph, amplitude of 1. So I move from 1 to negative 1 and start my graph with sine, which normally starts at 0, goes to 1, back down to 0, to negative 1, and back to 0. Draw my graph, and I should be all good. Now again, you can check this, not a problem at all, by plugging these values in and seeing if indeed your answer checks. If I plug in pi over 6 to this, I have sine, and I'm going to go in terms of 6 here. Pi over 6. This is plus. Instead of pi over 3, I'll use 2 pi over 6. And that's basically sine of 3 pi over 6, or pi over 2, and sine of pi over 2 is 1. So it checks. We'll cut the checking and just assume that I've done it right from here on out. Let's go through a few more. this is a standard cosine graph, no k value for the period change, no vertical translation value. So what I know is I know my amp is 1, my period is 2 pi, my intervals pi over 2, the phase shift is pi, and my vertical translation is 0. Go ahead and graph. I'm going to start over at pi. I'm going to add pi over 2 to that. I add pi over 2, I get 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and there's my 2 pi interval. It's a cosine graph. I'm going from 1 to -1 as an amplitude. Cosine starts at 1, goes to 0, -1, 0, back to 1, graph. You'll notice all these look exactly like sine and cosine graphs. It's just their coordinates on the intervals are changing or their amplitudes are changing. So in this case, you'll notice this 3 is located outside of the function itself. So this acts like a vertical translation. And if I'm going to take and graph that, I still know my amplitude is 1. My period is 2 pi. So my intervals are pi over 2. My phase shift is 0. But my vertical translation is -3. So here's what I'm going to do. Here's my midline, 0, pi over 2, pi, 3 pi over 2, 2 pi. And what's happening now is my whole graph is shifting down 3. So here's 1, 2, 3. What I'm going to do is I'm going to just put a dotted line here to give me some kind of indication as to where my center of the graph is going to be. So what happens now is if I'm to label this, here's -3, -4, and -2. -3 is acting like my midline for cosine. And cosine, when it starts at 0, is usually 1 above the middle of the graph. So what I'm going to do is I'm going to go 1 up from that midline. Then it goes to 0, -1, 0, +1 above the midline. So my graph looks like this. Cotangent graph with a, again, vertical translation, amplitude, 1, period, is equal to pi since it's cotangent, intervals, pi over 2 since I divide by 2 instead of 4 in this case, and vertical, 1, phase shift doesn't exist. Going to graph 1 period of this. So normally, we start here at 0, go to pi over 2, then pi. This time I'm moving up 1, so I'll put a 1 here. Have this little horizontal coming across. And say, alright, well, at 0, my normal cotangent value is undefined. At pi over 2, it's 0. And at pi, undefined again. So in this case, we know the cotangent at pi over 4 is 1. So somewhere over here is where it goes through. And there's my graph. Keep moving. So here's our first case where we have a period fluctuation and a phase shift, since they're combined within function itself. So again, what I like to do is say this is the same as sine of 3 times theta minus pi over 3. So when I do it this way, I have all the information I need. I have my k value here and my phase shift value here. Let's go ahead and identify everything. My amplitude is 1. Since k is equal to 3, phase shift, period, is equal to 2 pi over k. And my intervals, dividing that by 4, so I get pi over 6 is my intervals. My phase shift is equal to pi over 3. And since my intervals are in 6, what I'll do is I'll change my phase shift to 6. So that goes to 2 pi over 6. My vertical doesn't exist. So let's go ahead and graph this sine function. Since my phase shift is 2 pi over 6, that's where my sine graph will start this time. I have an interval of pi over 6, so I go 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. And you'll notice between these two is 4 pi over 6, which is 2 pi over 3, or 1 period. I'm going to graph sine from here. Has an amplitude of 1, so I go from 1 to negative 1, and just graph a regular sine function starting at 0, 1, 0, negative 1, 0. And I go ahead and graph. Let's do it again. This time we're going to graph a secant, which we know is a reciprocal of cosine. So I'll start by graphing a cosine and then do all the flipping necessary. I'm going to put this in the correct form. So we know that in this case we have secant, factor out 2, theta plus pi over 4. Again, there's my k value. The phase shift deals with this guy here. Amplitude 1, k 2, so my period is pi with my intervals equal to pi over 4. Phase shift is negative pi over 4, since this is in plus form, and my vertical translation doesn't exist. So since my starting point of negative pi over 4 has the same denominator as my intervals, don't need to do anything different. I add pi over 4, get 0, get pi over 4 here, 2 pi over 4, 3 pi over 4, and you'll notice that has a period of pi. From negative 1 to positive 3 is 4 pi over 4, or pi. I'm going to graph first the cosine graph from here, and I know cosine goes from 1 to negative 1. Starts at 1, 0, negative 1, 0, positive 1. You know, my graph looks something like this. Again, this is a cosine graph and not a secant graph. So after this, what I'll do is I'll take the reciprocal of all these values. The reciprocal of 1 is 1. Reciprocal of negative 1 is negative 1. Reciprocal of 1 is 1. Any reciprocal of 0 is undefined. And then, as we've done before, take the reciprocal of all these values in yellow, get the blue, and there's my secant graph. So in this problem, we'll factor out again. We have pi over 2 times the quantity of theta plus 2. We can identify things here, k and phase shift. So once again, our amplitude, 1 period in this case, is equal to 2 pi over pi over 2, which in this case is equal to 4. So therefore, I have a interval of 1, because I'm dividing by 4. I take and have a phase shift of -2 and no vertical in this case. I'm going to graph cosecant, starting at -2, adding 1 each time. There's my period of 4. Since I have a cosecant graph, I'm going to start by graphing sine with an amplitude of 1. So I go from 0 to 1 to 0 to -1, back to 0. Just sketch out in yellow my sine graph. Now take the reciprocal of all these values. Reciprocals of zeros are undefined. One is 1, -1 is -1. Take the reciprocal of all these values, and the blue is my cosecant graph. This has got just about everything in it. So let's go ahead and do it. We have to factor in the first place. So we've got 4 sine a half multiplied by theta plus pi over 2 minus 3. So here's my amplitude, k value, phase shift, and vertical translation. So I have an amplitude, 4, period, 2 pi over a half, 4 pi, phase shift of -pi over 2, vertical down 3, or -3. So let's go ahead and do this. I'm going to back up pi over 2. Notice my interval in this case, I didn't write, I better do that. My interval is pi. So if I change that to halves, that's 2 pi over 2. So if I add 2 pi to this guy, my next will be 3 pi. Oops, I lied. It would just be pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Going from -1 to 7 gets me 8 pi over 2, which is 4 pi, and there's my period. What I'm going to have to do now is note that my middle of my graph is down 3, so I'm going to call this 0, -1, -2, -3. And from here, this is my midline, if you will. So I'll go all the way across. And my amplitude in this case is 4, so I'm going to have to move all the way up to positive 1 to climb 4. 1, 2, 3, 4. And then I'll have to cheat here. 4, 5, 6, and 7. So my graph is going to fluctuate between these two. And once again, we're graphing a sine graph. So my sine graph starts at 0, or my midline, goes up 4 at my first interval, back down to 0, down -4, and back to 0 or the midline. So my graph looks somewhat like this. Let's do it again with the tangent this time. Get y is equal to tangent factor pi times theta minus third. Add 1 to that. So once again, k, phase shift, up, down, amplitude, 1, period, is equal to pi over k, which is 1, phase shift, is equal to 1/3. Intervals are a half, and vertical is 1. So what I'm going to do with my phase shift in my intervals are get the same denominator, which is going to be 6 in this case. We've done this one before. So this is 2 over 6. This is 3 over 6. And let's go ahead and start. So if I'm starting at a phase shift of 2 over 6, adding 3 over 6 to that, that's 5/6. Adding 3 more, get 8/6. I'm going from 2 to 8, which is 6 over 6, period of 1. We're graphing tangent from a midline of 1 in this case, because that's our vertical translation. So here's 1. I'm going to draw this dotted line across. And normally at the midline, my tangent value is a value of 0 at my first interval, followed by undefined, and then 0 again. So if I was to graph a period of tangent, it would look very similar to this. Lastly, we'll write an equation of a function given some parameters. We're going to write the equation of a secant function with an amplitude of 7. So a equals 7, period of 3 pi. And I know my period calculation is equal to 2 pi over k. So I can find my k value here. K is just equal to 2/3. A phase shift of pi over 3 to the left. So that's a negative, and a vertical translation of 4. So if I write my equation now, I have 7 secant, and I'm going to put it in the factored form since it's easier that way. 2/3 times theta plus pi over 3 plus 4. And the book may go ahead and multiply that out. So if I was to do that, that's 2/3 theta plus 2 pi over 9 plus 4. I know it was a little long. That's all we've got for you. We will talk about it tomorrow. Make sure you do your My Math Lab, fill out the summary.